online teaching platform. We are still on how to differentiate implicit functions. We are still on how to differentiate implicit functions. We have a function here, y is equal to a fraction with a numerator of 5 and a denominator 1 minus x squared in bracket having an exponent of 3. And we are to show that a bracket of 1 minus x squared multiplying dy dx is equal to 6xy. All right. Now, you can see that the given answer is in implicit form. They have not isolated the dy dx. But given the function, you can see that the function is an explicit function. So we have to make it implicit by multiplying through with the denominator at the right hand side. So we can just cross multiply to get the function as an implicit function. So let's look at how best we can work on this. So we have our function to be y is equal to 5 divided by 1 minus x squared, or in bracket having an exponent of 3. So we can just cross multiply. So we have y, which is the same as y divided by 1. So y multiplies x minus, 1 minus x squared in bracket having an exponent of 3. Then 1 also multiplies 5. So we are going to get it as y multiplying 1 minus x squared raised to the power 3 equal to 5 times 1. So that will give us 5. So this becomes our new function, which is an implicit function. So we are going to differentiate each of the terms with respect to x. All right. Now looking at this term, the term at the left hand side, you can see that we have a term involving y, or a factor with y. One of the factors of the term is y, and the other factor is 1 minus x squared having an exponent of 3. So we need to use the product rule. So here becomes our u, and the whole of this 1 minus x squared exponent 3 becomes our v. You can equally interchange the u and the v, and you still get the same answer. So we are going to use our product rule, and that will be you differentiate your u, you maintain your v, plus you maintain your u and differentiate your v, all equal to, when you differentiate our constant here, the 5 over here, we are going to get it as 0. All right, so let us apply the product rule to the left hand side. So we differentiate our u, which is the y, we are going to get it as 1. So you get the answer to be 1, but because it is the dependent variable, we are going to multiply the result by dy dx, which is the same as y prime. All right, then you bring the v, which is 1 minus x squared, or having an exponent of 3. Then we repeat our plus sign, which is here, this plus. Then you bring the original expression for you, which is the y. Then we now differentiate our v. So we bring down the power, which is 3. Then we bring the expression in the bracket again, 1 minus x squared. We are using the shortcut form of the chain rule, minus x squared. Then you reduce the power by 1. So it's going to be 3 minus 1. Now, when you are done with this, you differentiate what is inside the bracket and use it to multiply it again. So we have 1 minus x squared in the bracket. When you differentiate, you are going to get negative 2x, and all equal to 0. All right, because the derivative of 5 is equal to 0. So this is what we have. So let us now simplify. So we have y prime multiplying 1 minus x squared having an exponent of 3, then plus y here will multiply this 3, and it will multiply the negative 2x. So we are going to get it as negative 6xy multiplying 1 minus x squared in bracket having an exponent of 3 minus 1, so it's going to be exponent 2. Then all equal to, let me write this one first. Here we are multiplying. All right, so, okay, I'm multiplying by -2. So we are going to get our right hand side to be the same as the 0. We are just repeating that part. So let us work on the left hand side. Let us simplify. So we are now making, let us look at what you are supposed to get. It said we should show that 1 minus x squared dy dx is equal to 6x. So we need to maintain our dy dx at one side and send the other ones to the right hand side. So we have y prime multiplying 1 minus x squared in bracket exponent 3. Now it will be equal to, now we are going to transpose the second term to the right hand side. So it becomes plus, that becomes plus. So consider it's negative here. It's negative over here. So it's going to be positive. So positive 6xy multiplying 1 minus x squared, all in bracket exponent 2, all equal to 0. Sorry, I've already transposed it, so there will be no equal to sign again. The equal to sign is rather here. All right. Now we are to find y prime multiplying 1 minus x squared equal to 6xy. But you can say that the 6xy is here. We have the 6xy, but we have an expression multiplying it. 1 minus x squared, or in bracket exponent 2. So we need to divide through by the coefficient of 6xy so that we can get only 6xy at the right hand side. So it's going to be y prime, then bracket open, 1 minus x squared or exponent 3, then divide it by 1 minus x squared exponent 2, then equal to 6xy in bracket 1 minus x squared exponent 2, then you divide it by 1 minus x squared exponent 2. So you can say this would cancel this, then you are left with only 6x. Now, when you take this side of the equation, 1 minus x squared, 1, then the numerator, we have 1 minus x squared. The base are the same, so we apply one of the laws of indices. Since they are divided, we are going to subtract the power of the denominator from the power of the numerator. So we are going to get it as y prime multiplying 1 minus x squared in bracket, then 3 minus 2 as the exponent equal to 6xy. All right. Then this will give us y prime multiplying 1 minus x squared exponent 1, because 3 minus 2 gives us 1, equal to 6y. And you could see that our y prime is the same as dy dx. So this becomes 1 minus x squared in bracket dy dx will be equal to 6xy. So you could say we have shown that 1 minus x squared dy dx is equal to 6xy, given the function y is equal to 5 divided by 1 minus x squared in bracket, or having an exponent of 3, and we are to show that 1 minus x squared dy dx is equal to 6xy. So this becomes the final answer. Thank you for watching. Please do not forget to subscribe to my YouTube channel, Maths with Ebefa. Bye.